Good morning. Today we will be discussing the topic about SFD and BMD. So I will try to explain it in the most simpler way possible. Okay, so let's consider a simply supported beam. Let's take a combination of two loads, an uniformly distributed load So uniformly distributed load is also called as rectangular load. Okay, so this rectangular load, it's very important why I am terming as rectangular load. Okay, so let's take roughly per meter and let this be point A and point B. Okay, let length of now let's solve this simple problem. Okay, so in order to solve this, so there is very simple steps. So first step is to calculate the reactions. So how do we calculate reactions? By using equilibrium equation. So step 1, calculate reactions. So in this we have three equilibrium conditions. So sigma H is equal to 0, sigma V is equal to 0 and sigma M is equal to 0. These three are equilibrium conditions. Okay, so whatever beam you take, if we need to draw shear force and bending moment directly, that beam should follow these three equilibrium conditions. So these three are conditions that help to maintain the body in the equilibrium state. Ante so a body ni atu itu kadalakonda maintain chesedi anamata. Okay, so sigma H, so there are no horizontal reactions in this beam, so we can ignore sigma H. Next we can go for sigma V. Okay, so vertical reaction, sum of all vertical reactions should be equal to 0. So the vertical reactions are, we have, since this is a hinged support, we will have a reaction at A, and in roller support we will be having reaction at B. Okay, we will also be having, but this will be equal to 0. Now considering sigma V is equal to 0, so upward forces RA plus RB is equal to downward forces. Okay, so since I have termed this as rectangular loading, when you are taking the load, you should consider the area of this rectangle. Okay, so 20 into length, 80 is the area of the rectangle, that is the total load that is acted on the beam, and point load you can take directly as 40. So this is 120 kilonewton. Okay, so let's keep it as equation 1. Now taking moments about any point, you can take about point A or you can take about point B. In this case I am taking about point B, should be equal to 0. Okay, so here look carefully, force into perpendicular distance. So moment is force into perpendicular distance. So here force is RA into distance up to this point is 4 plus 2 plus 2, 8. Okay, so sign convention which I am following is this one. So if you have any problem in sign convention, just watch my previous sign convention video. Okay, so link will be attached below. Here we are doing analysis from left to right, so clockwise is taken as positive. Okay, this is acting in the clockwise direction. And coming to the next load, 20 into 4, is the total area of the load. Since this is a rectangular loading, all the load will be concentrated on the centroid portion of the beam. Okay, so this centroid portion of the UDL. Okay, so from centroid portion to distance up to point B. Okay, that is 2 plus 4, 6. So this is acting in the anti-clockwise direction. So with respect to point B, that is acting in the counterclockwise direction. That is why we have taken negative, because left to right, clockwise is positive, so obviously counterclockwise will be negative. Similarly, this 40 is also acting in the counterclockwise direction. 40 into distance up to this point is 2. This should be equal to 0. Okay, 8 RA minus 20 into 4, 80 into 6, 480 minus 80 is equal to 0. Okay, so RA is equal to 560 by 80, that is equal to 70 kilonewton. So RA is equal to 70 kilonewton. Now substitute this in equation 1, we get RB is equal to 120 minus 70, that is 50 kilonewton. So with this we have successfully completed our first step. Okay, let's keep this aside. Now go to step 2. Okay, in step 2 what we need to do is we need to draw the shear force and bending moment diagrams. There are many methods to draw these diagrams. The one which I am telling will be a direct method. Okay, so you can draw very easily. Okay, the blue color which I am using indicates a given data. Okay, so that we can keep track of what's happening. So one for shear force and one other one for bending moment. So all we need as inputs are reactions at A and reaction at B. So we don't need anything else. We only need these 2 points. So simply these both dotted lines will be the reference points for me to draw the shear force and bending moments, or in simple terms these represents point A and B extended downwards. Okay, now that line is for shear force, and we will draw another one for bending moment. Okay, let's keep this aside. Now, so we got RA, reaction at A is 70. Okay, 70 kilonewton, and reaction at B is 50 kilonewton. Okay, once we got these two, we got a uniformly distributed load. Here you can represent as the conventional form, and as most of the textbooks and other reference books represent like this. Okay, and another one is 40. So this is 40, and this load is 20 kilonewton per meter. Okay, after this step what you need to do is draw the reference points again. So these ones are the load points. Ekkadaithe meeku load undo, there you just mark it. Okay, so I have marked here, and another load is at somewhere here at 40. This one also we should mark. Okay, why we are marking you can understand in a little bit. Yeah. So first look at this carefully. I will draw a small sign convention here. So this is our shear force sign convention, and this is our bending moment. Okay, these are just our reference points. So for shear force, upward is taken as positive. Since we are drawing from left to right, we have to take upwards as positive. Okay, so this is upwards. How much? This value is RA value. So RA is 70. So in shear force you take forces directly. Okay, forces direct ga తీసేసుకుంటాం. Okay, its shear force is a representation of forces in the beam. Okay, simple ga cheppalante that's not an exact representation, but manaku gurtunchukovalante remember it as forces, shear force. Okay, now here ee point vachesariki, okay, so before going into this, let's speak one more point. Okay, the shear force, bending moment for point load and UDL. Point load shear force will be having no variation. In bending moment, linear variation. For bending moment for point load, we'll have linear variation, and for UDL, we'll be having parabola. Remember this. This will be very useful now. Okay, let's keep it here. Now, here, that loads on the left side of the beam. So left side loads say we have 70 kilonewton and then 20 kilonewton spread over a span of 4 meters. Okay, 20 into 4 gives 80. So 70 upward is positive, 70 minus 80 gives minus 10. So that is why I have represented in the downward direction. Okay, minus 10. So this is 10. Okay, so another one, up to here we know that it's 70 minus 80. Okay, that gives us 10, and this one is minus 40. Again we have minus 40. So 10 minus 10 minus 40 is 50. Okay, so it will be around somewhere up to here. Okay, so here finally we will add the 50. So this is 50. Okay, now see, listen again. So first what we did is, we have the reaction at here, so upward 70, so we have represented directly. Okay, up to here we will subtract and balance the loads. Okay, 70 upwards, and then ee point vachesariki subtract the load, whatever load is acting downward, subtract that load, and we will be getting 70 minus 80, we will be getting minus 10, until in between there is no load. When you go to this point, there is another load 40, subtract the 40 from this 10, you have 50. Again you will move along like this, and in this point there is an additional 50 load adding. So you add it like this, the diagram will be closed. Okay, now look at the shape of the diagram. Here for UDL, for shear force, we have an inclined line. So join inclined. Okay, so here on there is no loads. If there are no loads, there will be no variation in shear force. Okay, this is the final shear force diagram of the given beam. So very simple. Okay, now coming to the bending moment diagram. So there is a small trick here. Okay, we need to know the maximum point of the bending moment diagram. Okay, that will be at this point. So wherever the shear force is 0, that will be the maximum point of the bending moment diagram. Okay, also for a simply supported beam, bending moment at ends is 0. Okay, for a simply supported beam, bending moment at end points is 0. So considering 0, look at here. So force into perpendicular distance is the bending moment. Okay, from here to here, what is the force? 50. Distance up to this point is 2. So this will be 100. Okay, I need not worry about anything else. So look at up to this point, we have a force only 50. 50 into 2 gives 100. That is acting in the anti-clockwise direction. Since I am drawing from right to left, okay, so our moving from right to left, anti-clockwise will be taken as positive. So positive direction 100. So in bending moment, you can calculate any direction. You can go from left to right or right to left. Okay, all you need to remember is the signs. Okay, if you are doing from right to left, take this one. If you are doing from left to right, take this one. Again, if you are having any doubt or problem in sign convention, look to my previous video. Okay, now if I need at this point, okay, I need at this point, okay, force into distance up to this point, that is 50 into 4, okay, minus 40 into 2. So 50 into 4 is 200 minus 80. So this will be 120. So this point will be 120. Okay, now coming from left to right. Okay, from at this point, look at the loads. we have 70 into 4. 70 into 4 minus 20 into 4 gives the rectangular load area and distance from centroid to here. So centroid will be at 2 meters. 2 to here is 2. 70 into 4, 280 minus 80 into 2, 160. So this will be 120. Okay. So we got 120. So since both sides we got 120. So bending moment we can calculate from any direction. So this is the proof. So we need to join this. Look at here. For bending moment for UDL we will be having parabola. So while drawing the parabola, remember you have to draw it like this. Why? Because we have maximum point here, somewhere here. Okay. And then for point load simply we will having linear variation. So join here and then join here. Okay. This is the bending moment area diagram. Okay. So simple. So if you have, okay, so this is shear force diagram and this is bending moment diagram. So very simple. Go through this video. If you have any doubt, just rewind and see. Okay. So the work for you to do is simply take one beam. Okay. In order to get familiarized with the topic. Okay. Take one simply supported beam and keep 2 point loads, and then a small portion of UDL in the middle. Okay, if you understand the concept of rectangular loads, okay, this will not be an issue for you. 40, 30 and 20 kilonewton per meter. Okay, kilonewton and then kilonewton. Okay. So all distances are 1 meter. Okay, so work or practice. So if you have any doubt in either problem, just type in the comment section. So in the next video I will upload the solution for this problem also. Okay, that's it. Thank you everyone. Just like and subscribe. Thank you.